Hi, my name is Slava Moudry, and I'll be talking about some benefits of using Citus and PostgresDB in high-throughput data pipeline application, particularly with the time series in application for the cybersecurity. Okay, so again, my talk would be about using Citus and Postgres for the cybersecurity applications, but you can find it also useful for any other application which requires time series data or any kind of data that's using takes quite some time to process. So about myself, um, I've been working as a database engineer with Postgres since version 8. I'm very excited to work with Postgres. I think it's a great database. I've been building a lot of analytics applications for this time during the last 15 years. And most recently, I've been working for several cybersecurity companies. Particularly, I had interesting project with Cloudflare, where we built second generation data pipeline that allowed Cloudflare customers to see the data and analytics. And you can see this information on my LinkedIn profile. So why cybersecurity applications? So in my opinion, cybersecurity applications have a certain unique set of features and requirements that are different from other applications. And as we go through the next couple slides, you'll see what are those. And I also think that Citus database is very uniquely positioned to solve many of the challenges that cybersecurity applications present. So in this slide, you'll see a typical data pipeline for cybersecurity application, which starts from the agents or endpoints on the left side. This is where your data originates. Usually, it's some sort of agents that collect log files from endpoints, and they run it in distributed data centers. Then those log files, which are usually similar to Apache log files, are pushed down to some sort of distributed queue. Distributed queue can usually be Kafka, but it could be something else as well. This is where data is stored in a very detailed form. So each line, each data element in the queue represents a specific request, HTTP or HTTPS. And the next step would be custom application that would aggregate and filter certain data elements from this queue, and aggregated data is next step is pushed to persistent storage. And persistent storage in some applications can be Citus database. Also, in the next steps, in the persistent storage or Citus database, you will see certain aggregations running to aggregate data to a even less granular and more formats that are required by later API calls. For example, you would imagine that the first step of aggregation and filtering will push 1 minute level data, while the next aggregation levels in the Citus database can generate can aggregate this onto 1 hour, 1 day, and 1 month. And all this data needs to be stored in the persistent storage. So then APIs, whether it's user API or ad hoc queries, can access this information. Let's go to the next slide. What are the unique attributes of the cybersecurity application? So interesting stuff about cybersecurity is that First of all, if you remember, the data can be replayed from distributed queue. So all the detailed data is still available in distributed queue. So kind of you think about data is more ephemeral, and most likely you only need to store several days of data in the very detailed form. In my opinion, it's usually, in my experience, it's usually like 3, 4, 5, maybe at most days, after which data has to be discarded because it just takes a lot of storage space as well. It takes um, uh, for maybe for security, you don't want to keep very detailed data. The other thing is important is that it's really hard to know the data structures because things like it's true for any other application, but in cybersecurity specifically, you will get new information in log files that needs to be populated through the data pipeline. So all these new data elements need to be processed and stored and later available for user APIs. So you cannot really rely on the static schema. So this data elements can change. And then also the other thing is that data can be very different from one account to another. So one customer can have billions of requests per day. The other customers have only very few requests, like a small website. So you'll see that data is kind of skewed towards some accounts, and other accounts have less data. So it's really hard to make queries work the same way as data different from one customer to another. And also, ad hoc queries can come at any moment, and you will need to return the result set while the pipeline is running smoothly and keeps processing the data. So what are the unique problems and how Citus and Postgres fixes those or have a solution for those? Our first big problem is large data set and particularly large ingest volume. So this whole pipeline needs to work smoothly. If something stops working in the pipeline and things get backed up, it's usually really hard to recover from the situation. So it's better just to keep things running smoothly, and this way, you don't have a lot of problems, if possible. So Citus and Postgres allow you to do a couple things there. Particularly, Citus allows you do the horizontal partitioning, which means like you add in more nodes to your Citus cluster, and it allows data to be ingested faster. Then Postgres has improved partitioning, and you can also partition the table vertically, and as it's really important because you have time series data. So storing time series data in partitions make a lot of sense. So you can get rid of old partitions without locking your tables for a long time. Then you have also ability to optimize certain things like using unlock tables, which don't require any write ahead log files, as well as any inserts that you do while you're processing data through pipeline. They're not blocking read queries, so that's also an important part. About unique data structures that generally are supported by Postgres are particular important are IP addresses that you can store. You can index, not only store, you can also index them, and you can index the ranges, and that allows you to run a lot of queries without huge performance hits. You also have ability to put a lot of data into arrays that allows you to optimize your data structures, as well as there are other flexible data structures which are supported by Postgres, like JSON. I want also to specifically talk about business, indexing, particularly Brin index, which is a very important part that allows you to create a very small index and this index, it will be lossy, but it still allows you to query very efficiently. But the most benefit you get from the index is that it's really, really small footprint on the disk, and makes it also very easy to create and support. The other important part is hyperlog log. This is particularly useful for the data structures that for which you want to count distinct. For example, counting distinct of unique IP addresses is usually very CPU consuming and a very expensive operation, as you cannot really utilize the multiple nodes distributed query. In most cases, because of the same IP address can appear on multiple shards of the table, you have to bring everything into one place and then sort it out and count the uniques. Hyperlog log structure allow you to do approximation, very close approximation of the uniqueness of the data set. And Postgres and Citus supports it very well. And we've been using it pretty successfully for many queries. And the other thing is people not usually think it in the beginning, but later on, maintenance and costs kind of comes into play. And it's really important to realize like how much you'll be paying, not just now, but also down the road. From my experience, Citus database costs are very predictable and pretty much proportional to the increase of those costs will be proportional to the increase of the data volume. You won't get, you don't have to pay a lot more money if you require a certain feature, because usually this is already supported by SQL. You can just write different query. So let's see, what else can we do about tuning Citus to make it best perform for those kind of applications? The main and the most important decision you'll be making when you design your application for Citus is choosing the right distribution key. Why distribution key is important is because you want to make sure that your Citus cluster is balanced, meaning that the data that's ingested in the cluster is spread across all the nodes very evenly. If this doesn't happen and you get a skew, one node get a lot of data while others sit idle, what it means is that at the end, your queries will be waiting for this one node to come back with results while other nodes will sit idle. So it's really important to spread your data evenly. Additionally, the time series nature of the data for cybersecurity allows you to partition your data vertically. This is done by native Postgres partition. So in addition to distribution, you really want to think about how partition the table. And in my opinion, partitioning is pretty much achieved very well by using the timestamp or some sort of a time key. So for the other optimizations, I used a lot of unlock tables. So unlock tables is special tables, which are kind of temporary tables. So don't store persistent data there, because if server restarts or node in Citus cluster restarts, you may lose. You will lose, basically, you're guaranteed to lose all the data in those unlock tables. But for any intermediate storage or any temporary tables that might be part of your aggregation pipeline, they perform much faster. Also try to optimize inserts by using a copy command, and also play with concurrency. So you have in data pipeline, you have ability to add more concurrent processes, which will all simultaneously write to Citus cluster, or you can increase the batch size of each individual inserts. So you can play with those parameters to achieve the best performance, and it depends on your hardware or how big is your data is. But there are a lot of good ways to optimize this process. The other thing more related to database parameters, you want to make sure that the auto vacuum process that runs it is able to finish up. So I see many times that default settings for auto vacuum are very conservative, and it's better to check them before you run into issues. So in particularly, pay attention to the vacuum costs to make sure like after vacuum does not stop running after a certain period of time. It actually is able to finish the job that it needs to do, as well as tweak up max parallel workers or maintenance workers. On most current database hardware, you will get a lot more CPU threads, so you can add more parallel workers to help out the vacuum. And also when you insert in a table and you know this table would be read-only, my recommendation is to after you inserted the data, just run, analyze, and vacuum freeze this data. So Postgres doesn't have to go back and revisit this table after a while, and there is no need to update the transaction ID. The last point here is that resource management is difficult. That's a pretty complicated topic, and many databases have different ways to manage resources. Specifically for the analytical database, when you run a query, database is actually trying to give you as much resources as available to that query. At the same time, it doesn't really know ahead of time how many queries you plan to run. So managing those resources, giving resources to one query or reserving some number of resources to make sure that other queries can finish is pretty complicated problem. So there is no easy solution for this issue, but you want to make sure like you have enough available resources to process the data coming through the pipeline, as well as process any user queries or any ad hoc queries that run at the same time. So features that make Citus great, in my opinion, are ease at which you can add new aggregates or any new schema changes you can add. You pretty much write a SQL query and materialize the result set. So for example, at the last step of the pipeline, if you want to add more aggregates, like aggregate data from a minute level to hourly or daily level, it's pretty straightforward to do. Citus again has a very minimal locking. Your writes don't block your reads, so you can run those queries while the data is being processed, as well as recovery and rebalancing. There are a lot of great functions that allow you to rebalance the cluster, and since the data for the application is for this particular type of applications is ephemeral, you don't necessarily need to worry too much about backups and high availability. Again, you probably can rely on the fact that there is a replication factor and set a replication factor to more than 2 or more, and then it will basically allow Citus to spread your data, spread every shard on at least 2 nodes, so you can tolerate the failure of a single node, and then once your node gets back online, Citus provides you really good functions to rebalance the cluster and get back online pretty quickly. Some of the areas on improvements are I run into certain issues with upgrades, particularly like earlier versions of Citus, and with Postgres coming up with new partitioning scheme, Citus upgrading Citus with the new Postgres partition was really tricky, particularly if you use additional contrib module like pgpartment. That was pretty tricky to do. So just pay attention. And honestly, I think those issues were mostly fixed in the recent versions of Citus. There was another issue which Postgres, native Postgres supports, is different transaction isolation levels. Citus was only supporting read committed transactions, but I believe this might have been addressed in the most recent version of Citus. Okay, well, this is kind of wraps up the talk. I'm really happy that Citus is not just it's not really just a database that runs pretty smoothly for this kind of applications. It also, important part is that the Citus database is not a fork from Postgres, but it's actually extension that's built on the top of Postgres, and it means that it's pretty quickly updated once a new Postgres version gets out, as well as Citus team and Postgres team kind of contributing back to each other, and yeah, and everybody, community get benefits of both worlds of sharded Postgres and distributed version of that. Thank you very much.